and it is called ionic radius. Now, ionic radius is the measure of the size of an element's ion. Remember, ions are charged atoms. That's what an ion is. All right? You actually know what the charges are for most of the elements on your periodic table. They're the oxidation numbers that we placed on your periodic tables. That +1, +2, +3, ±4, -3, -2, -1. Those are the numbers that those specific families form ions in. Now, when we get to ionic radius, we have to remember a number line. Because the size of an ion is based off of the charge that ion carries. So down here we have our +4s, and on this side we have our -4s. And right in the center is where you would find a neutral atom. All right, and then we're going to walk our way up. So this would be -1, -2, -3. And then on this side, we have the same. So this would be +1, +2, +3. Our +4 is the smallest. Our -4 is the largest. And you can see how that affects our neutral atom. So if we were comparing a neutral atom to its ion, if the ion is positive, then the neutral atom is larger. If the ion is negative, then the ion is larger. All right? So that's what this right here tells us. If we have a positive ions are smaller than the atoms are itself. If we have a negative ion, they become larger than the atom itself. What if they have the same charge? Alright, if you end up with two ions of the same charge, then you're going to refer to the atomic radius rules. So that's the rules that we just covered in trend 3. So if we end up with two elements with the same charge, then we're going to look back at how big their atomic radiuses are in order to know how their ions compare. So let's put these from smallest to largest. And let's say we have aluminum, which is +3, potassium, which is +1, magnesium, which is +2, and sulfur, who is -2. Alright, so I'm looking for the smallest one. Alright, so which one would be the smallest?
AL.
It would be Al, because it has the highest positive charge, so that would make it the smallest. All right, what would be the next one? Mg. All right, next we would have potassium. And our largest one would be S. So our largest one would be sulfur. Alright, let's do one where we encounter the same charges, because that's going to happen. So let's say we have strontium, who's a +2. Magnesium, who's a +2. But then we also have phosphorus, who's a -3. And we have sodium, who is a +1. Alright, so who is the smallest? Or who's it going to be between anyway? SR and Mg. Alright? Since they have the same charge, we have to look at the atomic radius rules to figure out who is actually smaller. So the smaller one is going to be the one who's located higher up in the family. So which one would that make it? Mg. So Mg is smaller than Sr, so it would come first. All right. Then after that, we've got different numbers, so what would be next? Na. And last would be phosphorus. All right, what if I had one that asked which is larger? And it gave us Na +1 or Na. So this is asking us which is larger, the ion or the atom. So for this one, who is larger? Is it the positive sodium or is it the neutral sodium? It is the neutral sodium. All right? So they could also ask you questions that deal with a comparison between two. Which one is larger? Which one is smaller?